This is S. Muthukumar from Department of Mathematics, K.S.Rangasamy College of Technology. In this video, I am going to explain about the theory of inference for statement calculus. Definition: the main aim of logic is to provide the rules of inference to infer a valid conclusion from certain given premises. The theory associated with rules of inference is known as inference theory. If a conclusion is derived from a set of premises by using the accepted rules of reasoning, then such a process of derivation is called a deduction or formal proof, and the argument is called valued argument or valid conclusion. There are two types of rules are used in the inference theory. The one is rule P. In rule P, a given premise may be introduced at any stage in the derivation, and the other is rule T. In rule T, a formula S may be introduced in a derivation if S is tautologically implied by one or more of the preceding formula in the derivation. Now these concepts are explained in the following examples. Show that S or R is tautologically implied by P or Q, and P implies R and Q implies S. That means derive a conclusion S or R from the premises P or Q, P implies R and Q implies S. So using these three premises, we have to derive the conclusion S or R. In this step 1, rule P is followed. That is, given premises P or Q is used. In step 2, rule T is applied for the step 1. That is commutative law. That is interchange of P and Q. P or Q is equivalent to Q or P. In step 3, again apply the rule T. That is, P implies Q is equivalent to negation P or Q. Therefore, Q or P is equivalent to negation Q implies P. In step 4, the given premises is used. P implies R. Next, apply the rule T for the steps 3 and 4. That is, use the hypothetical Slagosian rule. P implies Q and Q implies R is equivalent to P implies R. That means negation Q implies P and P implies R is equivalent to negation Q implies R. In step 6, use the rule P. That means given premises is taken here. Q implies S, third premise. Now apply the rule T for step 6. That is, contrapositive rule is followed here. P implies Q is equivalent to negation Q implies negation P. Therefore, Q implies S is equivalent to negation S implies negation Q. Next, to follow rule T for the steps 5 and 7. That is, again apply the hypothetical Slagosian. Therefore, negation Q, negation S implies negation Q, and negation Q implies R is equivalent to negation S implies R. Finally, follow the rule T for the step 8. means P implies Q is equivalent to negation P or Q and double negation. Therefore, negation S implies R is equivalent to S or R, which is the required conclusion. Therefore, S or R is tautologically implied by the given compound premises. The second example, show that negation R implies S follows logically from the premises P implies R, negation P implies Q and Q implies S by using CP rule. CP rule means conditional proof rule. So in conditional proof rule, we have to assume one additional premises from the required conclusion. For this problem, the additional premises is negation R. So use this additional premises with the given premises and derive the conclusion as yes. So here the given premises are P implies R, negation P implies Q and Q implies S. Here the additional premise is negation R because of conditional proof rule is followed in this problem and the conclusion is yes. So we have to derive this yes by using these four premises. In rule 1 and 2, in step 1 and 2, rule P is followed. That is given premises are used. Now apply the rule T. That is derivation formula for step 1 and 2. That is hypothetical syllogism. P implies Q and Q implies R equivalent to P implies R. Therefore, negation P implies Q and Q implies S is negation P implies S. Again, apply the rule T for step 3. Means contrapositive rule is followed. Here P implies Q equal to negation Q implies negation P. Therefore, negation P implies S equivalent to negation S implies Q. In step 5, given premises is used. This rule P is followed. Again, apply the hypothetical relation. That is rule T for steps 5 and 6. P implies Q and Q implies R equal to P implies R. Therefore, negation S implies R. Again, apply the rule T for step 6. It is contrapositive rule. P implies Q is equivalent to negation Q implies negation P. Therefore, negation S implies R is equivalent to negation R implies S. Now, finally use the additional premises as rule P. Negation R is used here. Then apply the rule T for the steps 7 and 8. That means P comma P implies Q equal to Q. Therefore, negation R comma negation R implies S equivalent to S, which is the required conclusion. So, hence negation R implies S is logically derived from the premises P implies R, negation P implies Q and Q implies S by using conditional proof rule.